Okay, so in the previous lesson, we have covered 5 strategies: repeated identity, equal fractions, external unchanged, internal transfer or total unchanged, and constant difference. Okay, and I've recorded the lesson. Those of you who were not around or who could not make it for the previous session, okay, you can always click on the video link here, or you can go to Edufront YouTube channel and you can search for the previous session. Okay, so in the last lesson, we've covered 5 strategies. Okay, these are quite a common strategy that you can. It's not easy, but it's something very common that is usually used in the topic of fractions, percentage, and ratio. Okay, and it's good that you learn some of them. For some of the strategies, even at P4 level or even at P3 level, you have been taught, but of course with smaller numbers. But I do have students who are at P6, they still do not understand or are not familiar with some of these very, very basic strategy. Okay, that's why I have this webinar session. Okay, and I invite P5 as well as P6 students, okay, to to introduce you to some of these common strategies that you can use. Some of them are shortcut. They are alternatives to what you are familiar with. Okay, and they are simpler and more efficient method so that you can solve the problem faster in your exam. Remember, in your exam, it is under time constraint. Okay, it's you're given a certain period of time. So not only your answers have to be accurate, you're working to be accurate, you must solve under a certain time constraint. Okay, so it's very important that you learn as many strategies as possible, which can help you solve problems accurately and as quickly as possible. Okay. All right, so this is the previous lesson. So in today's lesson, we are going to cover 1, 2, 3, 4 more strategies. So these strategies are very, very a little bit more challenging than the previous one. Okay, we are going to cover branching method or the remainder concept. Secondly, number times value. Strategy number 8, supposition or the assumption strategy. And strategy number 9, the external change method. Okay, any of you are familiar with all these strategies? You have heard or you have seen these strategies before? Any of you? You can leave your answer. Only one? Okay. Farah, which strategy you are familiar with? All? Okay, very good. All right, Sarish, your strategy with, you are familiar? Okay. Alicia, you're familiar with supposition and branching method? Okay, some of you, Danish Amin. Is that Danish Amin? Danish, is that you? Because it's you're using your mom's name, I think. Okay. All right. Number 6, huh? Okay, very good. Okay, no problem. So I'm going to assume that all of you do not know this strategy. Okay, so we're going to start from scratch. All right, so it makes things very easy for everybody. So those of you who are familiar, is going to be a refresher, and you can see how these strategies can be implemented to the different kinds of questions. Please remember that these strategies are not like, it is the formula, the strategy that when you remember one strategy, you can apply to all questions. Okay, primary school maths or PSLE maths, the questions are non-routine. Okay, you cannot expect to remember certain formula, certain strategy, and then you can apply to any kind of question. There's no such thing. Okay, but you learn the basic strategy, and in the exam, sometimes you may need to fine-tune the strategies according to the question. All right, so sometimes you may even need to combine 2 or 3 strategies together to solve the question. Okay, so you will not be so straightforward and you can apply this strategy, this formula directly to the question. All right, so it's not so straightforward, but it's good to learn the very basic so that at least you have the skills or you have the knowledge to apply some of these strategies to the question given. Okay, let's take a look at the first one, branching or the remainder concept. Okay, the first strategy, branching method. Some books or some schools, your teacher may have said 3 method. Okay, 3 branching method, doesn't matter. Okay, basically it is using a branch. So I'm going to show you how it is done. We are going to start with a very simple question first. All right, let's read together. Mr. Tan used 1/4 of his salary and gave 1/3 of the remainder to his mother. Okay, so very important word here is that 1/3 of the remainder. Okay, not 1/3 of the total. 1/3 of the remainder to his mother, and he gave the rest of his money to his wife. What fraction of his total salary did he give to his wife? Okay, now this is a question on fraction. It's basically a P5 question. Okay, percentage of a remainder. Now this question can be solved using the model method. Okay, all of you are familiar with the model method. Okay, so you can draw, so 1 out of 4. Okay, so you can draw 4 parts here. So 1/4, he used his salary, 1/4 of his salary, and 1/3 of the remainder. So very important here. Okay, take note here. You must first, before you multiply 1/3, you must find out what is the remainder. Okay, so the remainder here is 1, 2, 3, right? So out of 3, 1/3 of it, right? So 1/3 out of 3 parts here is given to the mother, and the rest was given to the wife. Okay, so what fraction of the total salary of the total did he give to his wife? So you get half, right? Why half? Because 2 parts, okay, 2 parts out of 4, okay, you get 2 out of 4, it is equivalent to half. Okay, so this is very simple, very basic. You can solve this problem very easily using model, right? Okay, now let's go to a slightly more complicated question, slightly more challenging. The numbers are not so friendly. In the PSLE or in the exams, okay, sometimes you have questions which are not, or usually, depending on the marks. Paper 1, maybe the numbers are very friendly, very easy, but paper 2, the numbers are a little bit more complicated. Okay, so certain more complex problem, you need to use different strategies. Okay, like let's take a look at this question. Half of the class were boys and 2/3 of the boys. Okay, 2/3 of the boys and 1/4 of the girls. Now take note, they did not say 2/3 of the total, but 2/3 of the boys and 1/4 of the girls in the class were Chinese. What fraction of the total number of students were Chinese? Okay, let's solve this problem using model method, what we have learned just now. Okay, so first step here, so you have half of the class were boys, so we draw 2 parts here, 2 parts. Since half of the class were boys, so 1 part will be boys and the other part will be girls. Okay, so out of the boys, 2/3 of the boys were Chinese. So from the boys here, this part, we break it down into 3 smaller parts. So you get 1, 2, 3. So out of these 3, 2 units, okay, were Chinese. And for the girls, 1/4. So you need to divide this part into 4 smaller parts. So out of these 4 smaller parts, 1/4 of the girl were Chinese. Okay, so then the question asks, right, the final question, what fraction of the total number of students were Chinese? Okay, so the problem here is that you can see this part here and this part here, the parts for the girls and the part for the boys, they are of different size, right? If they are of different size, right, you cannot compare, right? You cannot say, oh, 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7 out of 7. 3 out of 7, okay, were Chinese. No, you cannot do that because the parts are of different size. Okay, so what do you need to do? You need to make the parts the same. This is the challenging part. So if you are using the model method, then you need to find the lowest common multiple of what? Of 3 and 4. Okay, now let's take a look. How are you going to do here? So, so if you use lowest common multiple, it can be quite complicating if you use model, because remember, you need to cut into smaller units, smaller parts. Okay, let's take a look how this cut. So you can see here, from here, right, from this model, you need to cut into much smaller parts. How many parts is that? It is 12. How do you get 12? The lowest common multiple of 3 and 4, which is 12. Okay, so when after you cut, you can see here, there are 12 here and then another 12 here, total of 24. So you can see it is, number one, it is complicated, and you are prone to make mistake, especially in the exam. Is going to be quite time consuming. So you can see this is 12. Imagine if the lowest common multiple is 74, okay, or 96. Okay, so how are we going to do? Okay, it's going to be very, very complicated. All right, so that's why we're going to I'm going to share with you this method called branching method. For the P6, those of you in my class, I'm sure you are very familiar because I've drilled in the class to you the different kinds of branching method. Okay, but for the P5 students, some of you may find this method quite new. Okay, but don't worry if you are not familiar with this branching method. I'm going to start from scratch and to show you how it is done. All right. Now let's see. This the same question just now. We are going to use the branching method. All right. Okay. Remember the first question. Mr. Tang used 1/4 of salary. So I'm going to use branching method. So I put the model method on the left side here and the branching method on the right side so that you can compare. Okay. All right. Let's take a look here. Okay. Danish, you don't understand? Don't worry. Okay. That's why this session is recorded. So later on, when I've given your parent the link, so you can always pause, rewind, repeat again and again. So that's the best part about online learning. Okay, so don't worry. That's why you are here, so that even if you are not here, also no problem. All right. So I know some of you are having prelims tomorrow and so on. Okay, so no problem. It's recorded so that you can pause and then you can rewind again and again until you are fed up to see my face. Okay, no problem. All right. So let's take a look at this question. So Mr. Tan used 1/4 of his salary. Now this salary is the total, right? So this part here is the total. So 1/4 of his salary, he used it. Okay, so the second part is where many students make mistake. They put 1/3 here. Okay, but remember, this is 1/3 of the remainder he gave to his mother. Okay, so what you need to do is that in addition to finding the fraction which is used, you need to calculate the remainder. What is the fraction remainder? So how to get 3/4? One whole minus 1/4, you get 3/4. Right? 1 whole minus 1/4, you get 3/4. It is remainder. So out of this remainder, 1/3 he gave to his mother. 1/3 of. Now what does of means? What does of means? Of means multiply, right? So 1/3 of the remainder, 1/3 of 3/4, you can see here. 1/3 of 3/4, you get 1/4, right? Cancel, you get 1/4. Okay, and he gave the rest of his money to his wife. The rest means what? Since 1/3, okay, of the remainder he gave to his mother, the rest of the money means 2/3 of the remainder. So 2/3 of the remainder means what? 2/3 times 3/4. So 2/3 times 3/4. So cancel, you get half, right? So you can see here, this is the final fraction. Final fraction means of the total. So out of the total salary, half of it he gave to his wife, 1/4 of the total he gave to his mother, and 1/4 of the total he used it. Okay, all of you got it? All of you got it? Danish, you got it? Very easy, right? Okay, let's take a look at the challenging, slightly more challenging question. Okay, remember this question? Okay, let's use the branching method. Let's use the branching method. Okay, so half of the class were boys, right? So these are the total number of students. Okay, so half were boys and the other half must be girls. Correct? No? Even they don't tell you that half boys, half girls, you must know, right? Because gender there's only two, one boys and girls. So if half are boys, the other half must be girl. So 2/3 of the boys and 1/4 of the girls in the class were Chinese. So out of half of the boys, 2/3 of the boys. Of means what? Multiply. So 2/3 of half, 2/3 times half, you get 1/3. You cancel two here, you get 1/3, right? Okay, so what about the girls? 1/4 of the girls were Chinese. So out of half, which are girls, 1/4 of half. 1/4 times half, you get 1/8. So 1/8 of the girls were Chinese. Okay, so this is 1/3. Okay, 1/3 of the students were Chinese boys and 1/8 of the total were Chinese girls. Okay, so they ask you what fraction of the total number of students were Chinese. So all you need to do is to add these two up, right? 1/3 plus 1/8, you get 11 out of 24. Okay, 11 out of 24. So that means, let's analyze a little bit more this fraction. So that meaning out of 24 parts, right, or 24 units. So 24 units represent the total, right? 24 represent the total number of students. Out of this 24, 11 parts or 11 units are the Chinese boys and Chinese girls in total. Okay? All right, very good, Tasina. Okay, I'm very happy that you understand the branching method. Okay, so right, so it's quite easy, right? So you can see the advantage. Now, what's the advantage of the branching method compared to the model method? Okay, number one, it allows us to see the different parts of the total at a glance. Okay, so what I mean by this, you can see here, this is a percentage of the total. We can see at a glance, right? Very clearly presented here. Secondly, it is very efficient, right? Very efficient. And thirdly, it is useful for question involving the remainder concept. Okay, you can see it is quite easy, especially if you have calculators, right? Paper 2, you can use calculator, you can solve this part here very easily. Okay? All right, okay, very good. Let's move on to the next method. Okay, are we ready, class? All right, so again, this session is recorded. If you don't understand, later on, when I give you the link, when I upload to YouTube, we can review again and again until you understand. Okay, so let's move on to the next question. Okay, Ashraf asks, do we still need to do simplest form even the question didn't say yes? As much as possible, your final answer, you have to leave it in the simplest form. Okay, all right, especially if they tell you in the question, leave your answer in the simplest form. But if they don't tell you, you did not leave your answer in the simplest form, they will not penalize you. Okay, because it's the correct answer. For example, if the final answer is half, so you put 2 out of 4, okay, they will not penalize you. All right, so don't worry about that. You have other more important things to remember, to worry about. Okay, let's take a look at the next question, which is number times value. Okay, have you all heard of this formula? Sorry, this strategy. Have you heard of this strategy? Yes, okay, very good. Now, there are several variations to the name, like some, in some books, they call it this grouping method, right? Grouping method, some number times value, right? And some set method, right? So various name, but the strategy, basically the concept is the same. Okay. Okay, let's take a look. What is this number times value method all about? So the purpose is to solve what problem involving two different variables of the same item where the number of items are in proportion. Okay, now this strategy is usually used in the topic of fractions, ratio, decimals, and percentage. Okay, so today later on I'm going to show you two examples. One is using fractions, the other one is on the topic of percentage. The P5 students, have you all learned percentage in school? Have you all learned percentage, P5 students? Yes? Okay, well then, just recently or a long time ago? Quite some time back? Or just recently, the P5 students? Just recently, yeah? Some just recently, some long time. Okay, so no problem, right? So percentage is something for the P5, it's not that easy for you to understand initially because it's the first time that you are learning percentage, right? But no problem. You need to practice, practice and again until you are familiar with the concepts of fraction, right? But I'm going to share with you number time value using a fraction, but very basic fractions. Okay, so no, don't worry about that. All right. So the clue to use this formula, you need to identify relationships and the two different variables. So I give you an example. Several questions they can ask you the number of coins and the value of coins. Now, the number of coins and the value of coins are different, right? Right. Let's say in my wallet, I may have 2 coins, right? I may have 2 coins, but one is 10-cent coin, the other one is $1 coin. So I have 2 coins, but the value are different, right? One of them, the value is 10 cents. The other one, the value is $1. Okay. So the value and the number of the coins is different. So 2 different variables. Likewise, you can have the number of cake and the price of the cake. They are different, right? I buy 1 cake, or let's say I buy 5 cakes, and each cake costs, one cake costs $1, the other cake costs $2, the other cake costs $3, right? The number and the price, they are different. So 2 different set of variables. Okay, so we can use 2 methods. One is guess and check method, and the other one is number times value method. And I always tell my students, okay, for guess and check, if you have to use guess and check, that means you are in trouble. Okay, not that you cannot use, but try to use guess and check only if you run out of ideas. Okay, if you've got no other alternative, then you resort to guess and check, and even that you do last. Okay, don't do in the middle of the exam because you're going to take a lot of time, and usually sometimes you make careless mistake as well. Okay, so I'm going to show you common method that students who do not know number times value, they use guess and check. And then if you know number times value, there's an advantage for you. You can use number times value, which is a much more efficient method. Okay, let's take a look at this question. Okay, I give you 30 seconds to read this question. Yeah? Okay, so as usual, I'm going to start with a very simple question. Okay, there are twice as many $2 notes as $5 notes in a bag. Given that the total amount of money in the bag is $297, how many $5 notes are there? So you see, first of all, here they're talking about twice as number. Twice number means the number of the notes. And then the value is different. One of it is $2, the other one is $5, right? So you can see there are two different set of variables. One is the number of the notes, and the other one is the value of the notes. So there are two different variables. So you must treat them differently. Okay? And they tell you that the total amount of money in the bag is $297, and they ask you how many $5 notes are there. So here when they ask you how many, they're asking for the number. And you can see that the number is in proportion, right? Twice as many, so that means there are 2 times as many $2 notes and $5 notes. So they are in terms of proportion, or in terms of ratio, twice as many $2 compared to $5 notes. Okay? Yes. All right, let's take a look at, okay, so first method, those of you who do not know number times value, most students will resort to guess and check. As we know, guess and check is very complicated, and sometimes it takes a very long time, and the worst part is that after you complete, you get wrong. Okay, so many of students will resort to guess and check. All right, so it's not that it is not usable, it still can be used. Okay, however, it's going to be very time consuming. It's still an acceptable method in the PSLE or in the exams. Okay, so you can see $2 notes and $5 notes, the ratio is always in the proportion of 2 units to 1, right? Because as mentioned in the question, so 2 units of $2 notes and 1 unit of $5 notes. Okay, so I'm going to assume, or I'm going to guess, right? There are 2 here and 1. So multiply by $2, I get $4. 5 multiplied by 1, I get 5. 4 plus 5, obviously 9. Okay, this is not my target, right? Very far. My target is $297. So guess and check, you continue, go on and on until it meets your condition. Okay, so you can go on, move on, go on, and then until you get, you can see 66 $2 notes and 33 $5 notes. So in the end, you get 297. So this is an acceptable answer. So how many $5 notes are there? So you can see here, $5 notes is 33 as the answer. All right, so this is still a possible method. Okay, but we are going to show you using number times value. Alternative method, much more efficient, faster, okay, and it is much easier. Okay, let's take a look at the same question but using using number times value. Okay, all right. Okay, so what do you do in number times value? Very simple. First, you draw a table, a simple table, right? You don't have to use rulers and so on. Just draw using pencil, right? So here, the first column here is the notes. So this represent, first column here represent $2 and $5, and the number means the proportion. How many $2 notes and how many $5 notes? So they are given in terms of proportion or in terms of ratio, right? Twice as many, so 2 units and 1 unit. And what's the value? Value means 1 unit, right? 1 piece. How much is the value of the note? So this is $2, right? $2, and the value, the second one is $5. So what you do, you multiply. That's why the strategy is called number times value. Number multiplied by the value. $2, okay? 2 units times 2, right? So you get 4 units. 1 unit times 5, you get 5 units, right? So this is a number multiplied by the value itself. Okay, so in total, 5 units plus 4 units, you get 9 units, right? So these 9 units, represent one set, right? Represent one set or one group. That's why sometimes this strategy is also called the grouping method or the sets method. Okay, but remember your total amount of money is 297. So 9 units is 297. Let's find out how much is 1 unit. How you do that? 297 divided by 9, you get 33. So 1 unit is 33. The question asks, how many $5 notes are there? So how many $5 notes are there? So remember, they're asking you how many $5 notes. They're asking for the number. Number, not the value, not the total value of the $5 notes. How many means the number. So it is just 1 unit. So 1 unit, so 33 is the answer. There are 33 $5 notes. Okay, so they can also ask you, what is the total amount of $5 notes in the bag? So what you need to do? 5 units multiplied by 33. 5 times 33, okay, then you get the answer. All right, so it depends. They can ask you anything. They can ask you about the $2 notes. They can ask you the value. They can even ask you the total. But total here is already given to you. Okay. All right. Okay, let's try with a slightly more challenging question. Okay, slightly more challenging question involving percentage. All right, all of you have your piece of paper with you? All of you have your paper with you? Very good. Okay, I give you 3 minutes to do this question. Okay, everyone? All of you do in 3 minutes, huh? All right? You can use your calculators, no problem. Let's see who can get the answer first. Oh, can do or not? $20? No, not 20. Try, I want everybody to try. 20, no. Not 20. Can you try? Are you all trying or not? Tasina, Naufal, Iza, are you trying? Aira, this question will be easy for you. Okay, too complicated. Okay, don't worry. Okay, let's do this together. Can we do this together? Can? Can, All right. Okay, I have a few answers here already. All right, so far I've seen 1 correct answer. Okay, 1 correct answer. Okay, no problem. Let's do this together. Let's read this together. Each rock melon was sold at $5. So this is the price, right? This is the price, $5. Each watermelon costs 20% less than the rock melon. Okay, so we need to find what is the value of the watermelon, right? Rock melon is $5. So 20% less, watermelon costs 20% less. Okay, so it will be, the watermelon will be 80% of $5. So if you do a quick calculation, you see that the watermelon will cost $4, right? right? The watermelon will cost $4. So you already find the value, right? You already find the value. Let's find the number. They say that 60% of the fruits he bought were rock melons. So 60% of the fruits, that means 60% were rock melons. So that means the remainder 40% were watermelon, right? So you can see here, we have the proportion or the number of fruits represented in terms of percentage. Now remember, percentage and ratio, they are like brothers and sisters. I always tell my class, they're like brothers and sisters. Fraction, ratio, percentage. These topics are interrelated. So if you are weak in fraction, or if you are not very strong in fraction, you will confirm have problem with ratio as well as percentage. Okay, so if you want to be very, very strong in percentage, you need to be very strong in fractions and to be strong in ratio as well as percentage. Okay, but no problem, we'll do our very best. So question asks, how much more did he spend? So how much more? Take note here, how much more? They're asking for the amount of money that he spent, not the number of the fruits or the price of each fruit. They ask you how much more did he spend on rock melons than on watermelon. Okay, so we're going to start by drawing the table, number times value table, so that we can present the answer in the table form so that you can see all the information, okay, as clear as possible. So many students make the mistake is when you look at the question, you stare and stare and stare at the question for 5-10 minutes. Nothing will come out, right? Immediately when you read the question, straight away you either draw model or use any strategy that you have learned, branching method, ratio method, number times, whatever it is, write something. Okay, until you write something, if you do not write anything, that's where you'll be lost. Okay, so let's draw the table, right? Table, again, we start with the fruit. There are two types of fruit, the rock melon and the watermelon. Right? And the number is presented in terms of percentage here, right? So 60% of the fruits were rock melons. So if 60% were rock melon, the balance, 40% will be watermelon, right? And the price, right? The value is the price. So since rock melon is $5, watermelon costs 20% less. So 20% less will be 80% of $5, you get $4. So you get $5 and $4 here, right? So applying the strategy number times value, what you do, you multiply. Okay, so before that, you can see this is a percentage, right? We will convert everything to ratio or units. So 60% and 40%, simplify, you get 3 units. 40% simplify, you get 2 units. So 3 units is to 2 units. So you can see how when you are given percentage, you convert into ratio. Okay, so that you can apply this strategy easily. Okay, so that the numbers are cleaner. So 3 units multiplied by 5, you get 15 units. 2 units multiplied by 4, you get 8 units. And the total 15 units plus 8 units, you get 23 units. Okay, so 23 units is what? $460. Okay, so let's continue. So since 23 units is $460, 1 unit is $20. So you divide 460 divided by 23, you get 20. Now this is not the end. The question asks how much more did he spend? So how much more did he spend? So you can see here, rock melon, he spent 15 units of his money. Watermelon, he spent 8 units. So the question asks how much more? How much more? You need to find the difference, right? The difference between 15 and 8 units. So 15 minus 8, you get 7 units. So 20, since 1 unit is 20, 7 unit is 20 multiplied by 7, you get $140. So you spend $140 more on rock melons than on watermelons. Okay? All right? Okay, so this is quite a short method, right? This is the shorter method. This is the shortest method I can think of. Okay, you can, if you have any other alternative methods, yeah, you can try. You can always do, but this is one of the simpler method. Okay, of course, you can use the cash and check method, but it's going to be quite long. Okay, let's take a look at the next strategy. Okay, next strategy, the supposition or the assumption strategy. Are you all familiar with this? Okay, Hani say, Mr. Yang, is it okay to put the number of units as 6 and 4? Yes, no problem. Okay, here, if you do not simplify, you put 6 and 4, no problem. You get the same answer also. Okay, you get the same answer, right? Okay, let's take a look at the next question. Okay, Adawia say that you are confused with this assumption method. Yeah, very common. Many students find it confusing. Okay, so this strategy, it is quite common in the PSLE. Okay, in fact, in this particular strategy, I'm going to show how to solve this strategy using actual past PSLE question. So it's a powerful yet easy to use strategy commonly found in the more challenging paper 2 question. So, okay, let's take a look at an example here. Okay, this question is taken from PSLE 2013, paper 2, 15, question 15, which is a 4-mark question. Okay, which is a 4-mark question. Actually, it's not difficult. Okay, if you know this strategy, you can apply very easily. Yeah? Have you done this before? Okay, very good. This is taken from PSLE question. I'm sure some of you have done this question before, if you have practiced the past year question. Okay, now let's do this together. Meng sold a total of 368 large and small durians at the prices shown below. Okay, so large and small durians, 368. So in this question, they did not tell you how many large, how many small, but rather in total. Large plus small is total of 368. Okay, in the prices shown. So they tell you large durian costs $9, small durian costs $5. Very cheap, huh? Durian, nowadays durian costs $30, $50, huh? Okay, and he collected $2,760. How many large durian did Meng sell? Okay, so take note here, there are two variables here. There are two key variables. Especially the P5 student, you may be quite confused. Now, what do I mean by two key variables? Number one, here we are talking about the number of durians. How many large durian and how many small durians? Here in this question, they tell you the total, which is 368. Okay, the other variable is the prices of each durian. Large durian, $9 each. Small durian is $5 each. Okay. Now, many students who, if you do not know how to use this strategy, assumption or supposition method, confirm job that you all will use the guess and check method. Okay. Now, it's not, again, it's not that you cannot use, okay, but it's going to be very, very time consuming. Okay, if you have to use this method, no problem, go ahead, but try to do this question last. Do solve the other question first that you confirm no, and then guess and check you can do right at the end. Okay, now let's show you, I'll show you using guess and check anyhow. All right, so how to do guess and check? Okay, basically it's tikam. You're going to tikam how many large and how many small durian. Let's assume, let's say that large there are 300, small will be 300, and if large is 200, small will be 368 minus 200, you get 168. So since large 200, so since large is $9, 200 times 9, I get 1,800. And small, 168 multiplied by 5, I get 840. I get 2,640. Still, it doesn't meet my target. Remember, my target is 2,760. Okay, so we are going to continue again and again until you get the final targeted collected amount. Okay, so you can see here the final answer, 233 large durian and 138 small durian. Okay, so you can still use guess and check method. So you can see here, we try 1, 2, 3, 4, 5 before you get the correct answer. Sometimes some of you maybe try 15 times, 20 times, then you get the correct answer. So it's going to be really, really time consuming. Okay, so today I'm going to show you a shortcut method. Okay, we call this supposition or assumption method. All right. Okay, let's take a look at the first one. So how to apply this strategy? Number one, we are going to assume, right? We are going to assume either all the durians are large or all the durians are small. Okay, so in this particular question, I'm going to assume all the durians are small. Okay, I'm going to assume all the durians are small first. Okay, if I assume all the durians are small, meaning that how much money were collected? So since the total is 368 multiplied by 5. Since the small durian costs $5, right? So 1,840. I collect 1,840. I notice that this is very far off from the real amount. Obviously, it will be different, right? Because this amount includes the large durian, right? Because they are obviously small plus large durian. But here, based on my assumption of all small durians, we collect 1,840. So what we do, we find the difference, right? We find the difference between the actual amount collected and the assumption amount collected. 2,760 minus 1,840, I get 920. So this is the what we call the error, or the amount due to the large durian, right? Because this is my assumption of small durian, but remember, not all are small, some are large durian. Okay, so what we do next, we find the unit difference between one large durian and one small durian, right? What is the unit difference? The large durian costs $9 each, small durian costs $5 each. The difference will be $4, right? So what we do, 920, which is the discrepancy here, divided by the units different, $4, I get 230. So this is my answer, large durian, 230 large durian were sold. Okay, now I'm going to show you another one where I assume all the durians are large. No problem, you can do that. You can assume either all are small or all are large, you will get the same answer. Only that when you assume that all are large, we're going to need one more additional step in the end, which is very easy. Okay, let's assume all the durians are large, right? Okay, so if I assume all the durians are large, since large durian costs $9 each, 368 multiplied by $9, I get 3,312, right? So you can see this is far off from the actual amount collected. So I need to find the difference, right? The difference between the actual amount, 3312 minus 2760, the discrepancy or the difference is $552, right? And again, what I do next, I find the difference of one unit, or the difference of one durian, one large durian and one small. What's the difference? $9 minus $5, I get $4, right? And I'm going to divide 552 divide by the unit difference, I get 138. Now this 138 is small durians. I do not want small durians. The question asks how many large durians, so I just need to subtract 368 minus 138, I get $230. So you can see I get exactly the same answer as the previous part where I assume that all durians are small. Okay, easy peasy, guys. Easy peasy lemon squeezy. Yes. The P5 students, are you okay or not? Are you all confused? Okay lah, Asfa. Okay lah. A bit confusing, Maria. A bit confusing. Durian squeezy, Zafiri, you understand? 50-50. Okay, no problem. You must know, this is actual PSLE question, you know. So it may come out again in the exams. All right. You're really confused. Okay, no problem. Later on, you can watch my recording again and again. Okay. All right, let's move on. We are left with 10 more minutes. I got one big strategy to show you, the most complicated of all. The most complicated of all the strategy today, which is external change or external transfer with change quantity. This one, many students will be very confused. All right, external change method. Have you all heard of external change method? You've seen? Okay, I think those of you in my P6 class, recently we did this question. Okay, we did this strategy. Remember when we use units and parts, right? When you use units and parts, I know most of you look very confused, but this is quite challenging. And let me tell you that this strategy has came out in the PSLE before. Okay, this strategy, because it's not that I purposely want to give you something difficult, right? But the question, such question came out in the PSLE in the past before. Okay, and that's why we come up with strategies to help you to solve this kind of challenging problems. Okay. No, not the painting the room question. That one is very easy. Okay, let's take a look at this question. Now here, the purpose is to solve what problem involving changes to both quantities. Let me take my coffee. Okay, we can use two methods. One is guess and check method, and the other one is a simplified model method. Okay, model method or the BCA method. BCA means before, change, and after. Okay, those of you in my P6 class, you know I would have had introduced you to this BCA method quite some time back. Huh? Okay. So here in the external transfer with change quantities, the quantities which are different at the beginning and at the end. Okay, there are changes to both quantities. So what do we mean by this? Okay, let's take a look at this example. Then you can get a better understanding. Okay, the ratio of Johnny's marbles to Ethan marbles is 1:5 at first. Their mother gave Ethan 12 more marbles and Johnny 5 more marbles. The ratio of the number of Ethan's marble to the number of Johnny's marble became 4:1. So in the beginning, the ratio is 1:4, and then their mother gave Ethan 12 more marbles and gave Johnny 5 more marbles. We can see the quantities change are different. Plus 12, plus 5. And then in the end, the ratio became 4:1. Okay, so in the beginning, you can see the ratio is 1:5. And then the change, what is the change? The Ethan was given 12 more marbles. Johnny was given 5 more marbles. Note that the different changes were made by these two quantities, and in the end, the ratio is 1:4. Okay? Now, who wants to solve this question? Okay, can you all try, all of you? I give you 5 minutes to solve this question. Okay? Can? Try, whatever method that you know. Okay, whatever method that you know, try and solve. Okay, I give you 5 more minutes while I go to the toilet. All right? See you in a short while. Anis, you got your answer? Okay, somebody has started giving me the answer, but I will not tell you now. Okay, I will give a bit more time for all of you to try. Okay, try, no problem. I give you all 3 more minutes. Aiden cannot try. So we have a few answers here. 20, 35, 40, 20, 35. Units and parts. Cannot. Okay, no problem. Now let's do this together. Are we ready? Are you ready? Can we do this together? Oh, sure. Okay, come. Let's do this together. So we are going to solve using, I'm going to show you using guess and check, but this is a guess and check is strongly not recommended. Okay, so I'm going to show you, because most students, if you do not know how to do, you resort to using guess and check. So this is how students will do using guess and check. All right, let's take a look at this question. Okay, the ratio of Johnny's marbles to Ethan marble is to 1:5. Their mother gave 12 more marbles and Johnny 5 more marbles. The ratio number of Ethan marbles to number of Johnny's marble was 4:1. How many marbles did Ethan have at first? Okay, so using guess and check, how do you do this? Okay, since they tell you that the ratio is 1:5, okay, so we're going to increase the ratio by using the concept of equivalent ratio. So 10:50. Okay, let's assume it is 10 and 50. So when Johnny had 5 more marbles, so 10 plus 5 is 15. For Ethan, 50 plus 12 is 62. Okay, then we're going to check. Okay, you can use your calculator whether the ratio 15/62 is 1:4. If it's not, so you cross out. Okay, then if this cannot, then you increase the next equivalent ratio, 20:100. So you plus 5 plus 12, again is the ratio 25:112. Again not, you cross out, and then you continue until it meets your final condition, which is 1:4. Okay, so you can see here is that it's not that it is not possible to be done. You can be done, but it is especially when the numbers are big and complicated, right? You may take a very, very long time to do. Okay, all right. So I'm going to show you a method. We call this external change method. External change method. Okay. So what you do, you draw a table, right? You don't have to use rulers and so on. Just sketch using lines like columns and rows. So you present here Johnny's marble and Ethan's marble, right? The ratio is 1:5. And then BCA. BCA stands for before, change, after. Some of you are familiar with BCA, right? I've taught you in class, and some of your school teachers also, you learn this in class. I've taught you in class. Okay. Now, what we do next is that we put all the information inside. Okay, we have not calculated anything, just put all the information inside based on the question. Okay, so you can see here, in the beginning, the ratio is 1:5. Okay, so when mother gave Ethan 12 more marbles, so Ethan plus 12, and then Johnny plus 5. And then in the end, the ratio became 1:2. Ethan has 4 parts, Johnny has 1 part. Okay, now you can see some of you may be asking, teacher, how come initially you put units, and then suddenly become parts and parts? Okay, anybody can tell us? BPA, BCA is the same, no problem, okay? Anybody can tell me, why is it in the first ratio, you use units, and then after that, you use parts? Okay, now why? Why you use parts here? So that you do not mix this ratio with this ratio, because the before ratio and the after ratio, they are not connected yet. They are distinct. They are different. Okay, let me show you an example. Now, if you say that this is 1 unit, this is also 1 unit, and then by your argument, 1 unit plus 5 become 1 unit. Is it possible? No, it's not right, right? You cannot say 1 unit plus 5 then becomes 1 unit. Okay, 5 units plus 12 become 4 units. Doesn't make sense, correct or not? Okay, why? Because this ratio and this ratio, they are not connected yet. Okay, how to connect them? So there must be some form of linkage. Okay, you must link them. Later on, I'll show you how to link these two ratios. So at the meantime, you separate this, you represent this, the first ratio, the before ratio in terms of units, and the after ratio in terms of part. So here 1:5, then after ratio is 1 part is to 4 parts. All right, so what you're going to do now, next thing is that we are going to make the parts the same. We are going to make the parts the same by finding the lowest common multiple of this part. What's the lowest common multiple of 1 and 4? Anyone? Lowest common multiple of 1 and 4? 4, right? Very good. Okay, so what we do? We're going to multiply 4, right? Since lowest common multiple of 1 and 4 is 4, we're going to multiply 4 to all. Here times 4, times 4, times 4. Okay, 1 times 4 equals to 4. Right, remember when we multiply here, this whole thing we must multiply by 4 because these are linked together, right? So times 4, 1 times 4 becomes 4 parts. 5 plus times 4, you get 20. 1 unit times 4, you get 4 units. Here, you don't need to change anything, right? Because 4 remains 4 here. So what happens after you multiply? After you multiply by 4, you get 4 parts, 4 units plus 20, and this equals to 4 parts. So what do you observe here? What do you observe now? You can see here, 4 units plus 20 equals to 4 parts, and 5 units plus 12 also equals to 4 parts. Okay, can you see some linkages now? Right? Since 4 units plus 20 equals to 4 parts, 5 units plus 12 also equals to 4 parts. So it means that 4 units plus 20 must be equals to 4 units plus 12. Correct, right? Okay, very good. Now let's link them together. Okay, so next part, how are we going to link? Right, we can do 2 ways. One is using algebra. Secondly is to use model. Right, since many of you are confused with algebra, I'm going to show you using model. Okay, so just in case you need to use algebra, how? So that means 5 units, here, you can see here, 5 units plus 12, right, plus 12, right, 5 units plus 12 equals to 4 units, equals to 4 units plus 20. Okay, so those of you who are very good in algebra, you can solve this quite easy, right? Because this is 5 units and 4 units. You bring them over, becomes 1 unit. Okay, so 20 plus 20, this is plus 12, right? 12, you go bring to the other side, 20 minus 12 equals to 8. Okay, 1 unit is 8. However, if you are not very familiar with this algebra method, you can use the model method. Okay, you can use model method. How to use model method? Very simple. Since 5 units plus 12 equals to 4 units plus 20, we put them together like this, right? You can see here. This is 4 parts. This also equals to 4 parts. So Johnny, 4 units plus 20 equals to Ethan, 5 units plus 12. And then we compare. So you can see here this part here, right? So 5 units plus 4 units. So that means 1 unit is from here to here, right? So 1 unit is, see this 5 minus 4, you get 1. 1 is from here to here. And this part here is 20 minus 12, right? You can see here, 20 minus 12 equals to 8. Okay, so 1 unit is 20 minus 12 equals to 8. And then they ask you, how many marbles did Ethan have at first? Now, Ethan have at first how many units? Which is 5 units. So 5 units is 8 times 5, you get 40 marbles. Okay? Can class? Easy peasy lemon squeezy? Can do it, huh? This question came out in the PSLE before. Don't think that this is very challenging. It is very challenging, but unfortunately, these are the kind of question that you can see in the PSLE. So that's why I teach you different strategies. Of course, you need to learn and understand as much as you can, and then try to apply according to the question. Obviously, the same question will not come out again, but the same type of question may come out. Okay? All right. Everyone okay? Okay, we are a little bit